Hi, this is Jeff Heaton. Welcome to Applications of Deep Neural Networks with Washington University. This is the beginning of the fall 2021 semester. So in this video, I'm just going to kick off the class, introduce it. If you're taking this class through Washington University, I'm going to talk about, obviously, how you submit assignments and all that sort of thing. It's currently being offered online and in a hybrid format. In the hybrid format, you show up 4 times at the campus, and the rest is remote. If you're in the purely online version, everything's the same, except you watch the videos pre-recorded, or you can join in live if you so desired. Now, if you're just tuning into this from the internet through YouTube, everything is available to you, except you really can't submit assignments or get individual help and guidance from me like the actual students at Washington University. So the previous semester, we taught this class in a completely online format. I've been doing this throughout COVID. This semester, we'll play this day by day because such is the world of COVID. But at this point, the plan is that this course will meet at the Danforth University campus at WashU 4 times during the semester. Now, I'm going to broadcast that through Zoom, and it will be available recorded as well. So I'm not making class attendance mandatory this semester for those 4 in-session meetings. We'll talk more about that at the first meeting and in the Zoom. So all of the information about this course you can get to through the WUSTL Canvas system. The links take you primarily to my GitHub repository, which is where all of this stuff is stored. This is my page at WUSTL. I probably need to update my picture because I think the COVID beard is probably going to be a keeper, but the link to the site is here. And this has some general information about it. You'll want to go right to the course sessions on GitHub. If you are accessing this course through the Washington University Canvas system, it's going to look basically like this. All of the videos are available either through YouTube or through Kaltura. They're exactly the same videos. You can watch it through whichever one you desire. One thing that's neat about these is the transcripts are available, so you can search and find topics across the videos. That's available in Kaltura. You can also speed up the playback and watch me at twice the normal speed. I do that in videos all the time. Very, very useful. Each one of these will have something on the videos, so that's links to the videos in Kaltura on Canvas, and then there'll be the reading and then the program that is due for each class. If you click on the readings, it's going to take you outside of Canvas and go to GitHub. And this is what you see if you access it just straight through the internet. Really, everything in this course is available on Jupyter Notebooks. And Jupyter Notebooks are a great way to go about this course. When you're doing deep learning, you need to have a GPU available. Well, you don't need to, but some of the stuff that I'll show you in this course actually will not work, only with a CPU. Now, the computer I have behind me has a fairly high-end GPU on it. I use that. The Mac that I'm actually using right now, it's kind of an exciting time for Mac. You can now use the M1, if you have one of the newer Macs, to be able to use a GPU or an accelerator to make use of the high-speed mathematical computations that you need really for deep learning. I have a video showing you how to set up an M1 Mac exactly like you need for this course. And then also, if you're using Linux or Windows, you can also use the GPU in either of those. You do need an NVIDIA-type GPU because CUDA is required for TensorFlow Keras, which is what we're making use of in this class. Now, if you don't have a GPU on your system, what I very much recommend, and really, if you don't want to go through the steps of setting up a GPU on your system, because it does take a lot of software configuration, drivers and that kind of fun stuff, I do recommend Google CoLab. And all of the Jupyter notebooks that I have on this course have a link here at the top that says Open in CoLab. So you can simply click on that, and it will actually launch it in CoLab. Now we're in CoLab. I am using Google CoLab Pro. It's about $10 a month, not needed for this course. When we get into the Kaggle competition, it will give you an unfair advantage. And not unfair in the sense of it's not fair, you're allowed to use it. And some of the students do use Google Colab Pro during the Kaggle competition to have access to a faster GPU. You'll also have a really good GPU available to you inside of Kaggle. But we'll get more to the Kaggle as we go through the first class session here. So you can see that all of it is available here. You can run these various parts. Most of the first course module is just introductory material. There's not too much code until you get to the very end. So if you run this portion of the code, this is what checks to see that your GPU is actually available for you. And you see the little spinning thing there. It's spinning, and it will tell you if the GPU is available or not available. It'll tell you the version of TensorFlow that you're dealing with. So here it is TensorFlow 2.5, which is what I tested all the code on for this semester. Since the GPU is not available, what that means you need to do in CoLab is go down to change runtime type, turn on your GPU. It's going to restart your virtual machine, which is fine. Now we go ahead and run it, and your GPU should be available. Yep, GPU is available. That will considerably increase the processing speed on all of this. If you want to use CPU only, you can probably get through about 90% of the course. I will say the Mac M1 support is quite new. I've only had this Mac M1 myself for about a month, but I'm running through all of the course material on M1 and fixing any incompatibilities as I run into those. Just about everything, probably 95% of the course, would work with a Mac M1. There's one small area that's just not going to work, and that's where we get into StyleGAN, which is where you use GANs to generate computer-generated faces, because that code was specifically created for NVIDIA CUDA. So have a look at the videos on getting started with CoLab, getting started if you want to actually run it on your Mac. I've got videos showing how to do all of that. Pick your path. If you're not a nuts and bolts configure drivers kind of person, and that's fine. Machine learning engineers sometimes are not. You can just use CoLab. Usually probably about 70 to 80% of the students use CoLab. So I give you instructions here. These are the links, just how to use CoLab, how to set it up on a Mac, and so on. I also have a video on how to set it up on a Intel Mac. Intel Macs, you won't have the acceleration, but you'll at least be able to run things. So these are the assignments for the course. We'll have an icebreaker. That is where you post something about yourself to the rest of the students. I'll read every one of these because I'm very curious about what your background is, what you've done. If you're interested in, I don't know, career directions on AI, machine learning, whatever, I'll reply to every single one of the icebreakers. If you ask me something or give me something to comment on, you'll definitely hear back from me when I go through all of those. Class assignments are 50%. Those are due each week for the first part, the first 10 sessions of the course. These are small programs that test your understanding of the material. Each one of these will take you maybe half hour to an hour to 2 hours to complete, maybe longer. Everybody does different parts of the course at different speeds. Some of them are more complex than others. The first one is really easy. It is just run it, and you don't even have to make any changes. It's just proving that you can run Python code, because this course is completely in Python, and submit a result. I use a auto grader, auto feedback program. So when you submit it automatically using an API key that I will send you, and you have to be a student of WUSTL to get access to that, because I have no way to grade you without Canvas, and I have no time to grade people who are not my students. So this is a program that I wrote it. It's completely my own creation. I actually use a neural network and regular expressions and other things to to grade these. It won't always be able to give you exactly a grade, but it will give you feedback and tell you, and you can submit this as many times as you want before. So if you want to just keep submitting, you should be able to get 100% on all of these class assignments. It'll tell you what's wrong, and it's going to check your output, let you know how it matches, how it doesn't. If you don't understand why your output is not matching mine, send me a question in either Teams or through Canvas or through email. Those are really the primary ways to contact me. There'll be a Kaggle project. You will have teams on this. You will pick your own teams, and the teams can cross the two sections. There's a completely online section, and then there's a meet at the university 4 times section. So you can join with other people. You can also join with people who are not even in the class. And typically, this is on Kaggle in class. So you'll have other people from the internet even pop in and compete with you. I'll do a ranking of who the top submissions are. The top, I would say 5 entries, I will have them the teams do a presentation at close to the final class so that you don't have to hear from me every single time that we meet. It'll be on the 4th class session that we would meet in class. The purely online students, we won't do that. You're certainly welcome to present on Zoom if you're one of those top 5. So I'll contact each of you when we reach that. Real Kaggles have serious prize money available to them. There's no prize money for these Kaggles, but what I will tell you is the top 3, I would say, I would be completely willing to write you a really nice LinkedIn recommendation talking about how well you did getting into the top position of the Kaggle competition. The students in previous semesters have really enjoyed the Kaggle. I think it's the most fun part of this class. It lets you compete against the other students and really see how good of a model you can actually produce. Then there's the final project. If you're one of those top 5, you don't have to do the final project, but the final project is your presentation will be your final project. For the rest of you, the final project is looking at and analyzing a paper, an advanced paper that was submitted at one of the premier conferences for deep learning, like ICLR or NIPS or something like that, basically writing a summary of it. Some of the papers that I choose that you can select from, because I give you around 10, are actually written by scholars here at Washington University. So that's kind of fun. These are all of your assignments. The first time that we meet at the university, I will go through how to actually submit an assignment. And if you want to follow along with me, you will have submitted your first assignment. And again, if you're connecting through the internet, you can certainly see the assignments, but you can't really submit them or get them graded or anything like that. So this is me, your instructor, Jeff Heaton. I have a Master's of Information Management from here at Washington University. I also have a PhD in computer science from Nova Southeastern University. I did that a little later in my life. I finished that in 2017, so I'm not exactly a traditional PhD student. I am a senior member of IEEE. My email address is jtheaton@the-domain of this university, and I've got some other certifications as well. You can see some of the links to my social media. I never really planned to be a YouTuber, but I started putting these videos online before WashU had Kaltura, and next thing you know, I have over 50,000 subscribers. So YouTube's fun, and I continue to put other videos onto YouTube. So as a student, I very much encourage you to subscribe to my channel. I don't know, smash the like button like YouTubers always tell you to do. But if you subscribe to the channel, you'll get other more advanced topics that go beyond the course as I release additional videos. I typically release about a video a week, sometimes just refreshes of the course material. I probably reboot 5 to 10% of this course every semester. I have a Discord server that you can discuss that's fully open to the internet. Inside of Canvas, I have a link to Teams There's a team inside of the WUSTL Teams system for students. I highly recommend you to try that out. I often chat with students if I'm available, and it's a great place to ask for help. You can see some of my papers on Google Scholar. Back when I was more in research mode, I haven't written a paper in a number of years. My profile on ResearchGate and ORCID as well when I was doing more papers. And that is me, sitting right here actually. Current resources, Google CoLab. We will use Python Anaconda if you're going to install it on your own computer. Actually, I recommend Miniconda, which is the slimmed down version of Anaconda. We will use TensorFlow. The two big competitors right now that are fighting it out are TensorFlow and PyTorch. I really like PyTorch as well. This course started in 2017 when TensorFlow was really just the one available. PyTorch is good, but this is by no means, they're fighting it out right now. And I wouldn't say either is particularly a clear leader. I'm seeing a lot more from PyTorch as far as support from academia on new papers coming out, especially papers with code. TensorFlow, I see a lot of support for it in some of the utilities that I use in my day job as a vice president of a data science group at a large company. So what is machine learning? Machine learning is learning from data. So you have traditional software development. You would take input data and you would write program code. You would run these on the computer and you would get the output. Machine learning, you get the output from cases in the past where so you've got labeled data perhaps, maybe you've got a bunch of images of cats and dogs, and you have them labeled cat and dog. You put that into the computer and it gives you the program code. The program code is the neural network. So this is called data-driven development, and this alleviates you from having to write a lot of the code to tell the difference between a cat and a dog, because that would be very, very difficult for traditional programming. These are the three areas that I really see deep learning used a lot. Predictive modeling. This is very much you have some inputs, you have an output in something like a spreadsheet, but now you've got new cases where you don't have that label, it's unlabeled data, and you want to form those predictions. Computer vision as well, think self-driving cars, think telling the difference between a cat and a dog. The assignment that I'm going to give you for Kaggle is going to be a computer vision problem, and it'll be a decently challenging one this semester. I always generate all the data for the Kaggle competition, so it's brand new. It's something you can't just Google and find potential solutions for on the internet. And then also time series, predicting things over time. Think stock market, think Bitcoin, think whatever. Obviously, I haven't cracked how to predict Bitcoin since I still have my day job and my night job. Regression, classification, these are all just ways. Regression is, are you predicting a number? Classification, are you predicting a class? Deep neural networks are just your classical neural networks, but they have been extended in so many different ways with convolution layers, recurrent layers, transformers, attention, all these sorts of things that allow them to do well beyond what they were ever capable of. The four individuals who are really behind this, Jan LeCun, Jeffrey Heaton, Yoshua Bengio, and Andrew Ng. Why deep learning compared to other machine learning things like support vector machines, random forest, gradient boosted machines? Neural networks, for one, they really excel at computer vision. They really excel at computer vision because the neural networks are able to create their own features. The way you would handle computer vision before is you would simply bring in additional images and you would engineer features out of them. You'd look at like the maximum color, you'd scan, you'd try to find individual details. Also, why deep learning? Andrew Ng described this really pretty well. Older algorithms, and if you're an academic researcher, older algorithms are the things you're not working on. Deep learning is what he and most machine learning researchers are focused on right now. If you have not that much data, so small data, the older algorithms will outperform deep learning typically. So Python, we're going to use Python, we're going to use TensorFlow Keras, We will use PyTorch a little bit in this course. We'll use it particularly for GANs, because that's just the software that Stallion 2 ADA, which is what we make use of, is available for. The entire course is written in Jupyter Notebooks. If you want the course textbook for this, that's available as well. I wrote it. It's based on all of the material that you have here. The textbook, just click here and it will open the textbook. It's a PDF. It is over 500 pages, and it is basically the same material that is on the Git repository, except it's very much in printable textbook form. Eventually, I'm going to publish this as an actual book that you can get on Kindle and buy paperback through Amazon. I just have not gotten to that yet. I update it each semester. So when you download it, I will have put the final changes in and it will say fall 2021. So that's it. That's the course. This was a quick overview of this. We'll talk more specifically about how to install this, how to submit assignments when we have the Zoom meeting and the in-person meeting this semester at the actual campus. Thank you for watching this video, and if you found this useful, please subscribe to my YouTube channel and considering clicking the like button if you're watching this through YouTube.